"What were you just thinking about?" she asks. Suddenly I don't remember. I am fully awake and my mind was just drifting somewhere. A fully elaborated space of imagination. Now I don't even know whether my thoughts were important. Was I laying out plans for tomorrow's lecture? Was I rehearsing a conversation I would like to have with my father, or an old friend who I should probably get back in contact with? Had I uncovered an interesting line of inquiry which I should pursue on the podcast? Was I ruminating over some slight I detected, some little disrespect I encountered? Did that perception have me feeling sorry for myself? Nah, maybe I was just going over some memorable scene in a movie I saw. Maybe I was making up a children's story or imagining a Dungeons and Dragons adventure or something. Now I don't know. I had it for just a second, and now it's gone. This is a typical example of daydreaming. One rarely even notices they're doing it. When you sit down to meditate, in the mindfulness tradition, you try to focus your whole attention on something simple and perceptible, like your own breathing. By this means, you hope to quiet the inner daydreaming, that behind-the-scenes commentary that runs through every waking moment, that distracted wandering of thoughts. They aren't usually a running monologue, a rambling of inner speech. Usually they aren't that explicit. And as soon as something calls your attention to events in the moment, as when my girlfriend asks what I'm thinking about, in this example, they fade into nothingness, perhaps leaving a trace of memory, but more often discarded from the world forever. Were there nuggets of brilliance in there, lost along with the trash? Wasn't there something I was thinking about that I really needed to remember? Never mind. It's too late now. I've always considered daydreaming to be something altogether different from dreaming as it occurs in sleep. The term daydream is just a metaphor. I mean, it doesn't feel like experiencing a dream. It's too subtle. It's just mind-wandering. I couldn't be truly disturbed or frightened by these daytime flights of fancy. But in a dream, I might be confused and terrified, trapped in a hallucinated ordeal. That's not what daydreaming is at all. In daydreaming, I'm not immersed in a world. I'm just thinking, right? But here I'd like to consider a different hypothesis. Suppose that dreams and daydreams have the same underlying mechanism. My first line of circumstantial evidence is that daydreams which occur in the waking state slip away from memory just as much as dreams in sleep upon waking. This suggests that there is no imposed amnesia responsible for the failure to recall dreams. Instead, it seems to just be the nature of passively thinking about stuff or fantasizing that the contents tend to disappear from memory. For that matter, when dreaming, we often find ourselves confused about what we've just been doing, about how we got where we find ourselves. We've just drifted from someplace into the current situation. We might be confused or upset by this because we think it's real. We feel like we're losing our mind. I'll accept that dreams are more emotional and captivating than daydreams, but that doesn't really make a difference to my first point, the amnesia effect. My second line of circumstantial evidence has to do with cortical function as it occurs in REM sleep versus waking states. It is very similar, which is what we would expect if there isn't a new kind of function taking place in REM sleep to account for our dreams. Of course, there are some differences, both phenomenologically and physiologically. In sleep, including REM sleep, norepinephrine activity is shut down. The prefrontal cortex is not as active, and this might account for our difficulty with rational thinking, doing math, and so on. I think it probably disables normal attentional processes too, but that's not the point. The point is that the same basic churning of thoughts and imagination might account for both dreaming and daydreaming. In the book When Brains Dream, Antonio Zadra and Robert Stickgold have a section called How Does the Brain Create a Dream? They write, quote, "We now have evidence that the patterns of brain activity generated when we see an object in the real world are pretty much the same as when we imagine the object, whether in waking or in a dream. The evidence comes from functional magnetic resonance imaging, fMRI studies, which can record activity throughout the brain over several minutes or hours. With fMRI, the brain is divided into about 50,000 voxels, three-dimensional equivalents of your camera's two-dimensional pixels. Each voxel is a cube of about 1/10 of an inch on a side, and a snapshot of the activity in each of these voxels is taken every 2 or 3 seconds. Using an exciting new technique called multi-voxel pattern analysis, researchers can determine the precise pattern of voxel activation produced in visual processing regions of the brain by a specific image, say a picture of a baseball, or the average pattern of voxel activation for a category of images, for example, faces, tools, or doors. Then, using these classifiers, they can have a study participant look at pictures and reliably predict whether they are looking at a baseball, a face, or a door, entirely based on their pattern of brain activation. This amazing tool has allowed us to confirm that the pattern of activity seen when you look at a face is also activated when you bring an image of that face back to mind from memory. But even more exciting is groundbreaking work led by Tomoyasu Horikawa, a young researcher at the ATR Computational Neuroscience Laboratories in Kyoto, Japan, who has now demonstrated that the same multivoxel patterns are activated when faces appear in our dreams. In a study right out of science fiction, Horikawa and his colleagues calculated classifiers for several categories of visual images from the fMRI signals generated while participants viewed thousands of pictures. When they matched these classifiers to the participants' brain activity just before awakening them from dream reports, the research team found surprising agreements between the classifiers that best matched the dreaming brain's activity and the content of the dream reports. After one awakening, a participant reported, "Well, there were people, about 3 people inside some sort of hall. There was a male, a female, and maybe like a child. It was like a boy, a girl, and a mother. I don't think there was any color." When the brain activation from the preceding 15 seconds was analyzed, the computer created a composite best-fit classifier image that contained the same multivoxel patterns of activity as when the subject had actually been looking at pictures of women and children. Unquote. So here's what I propose by way of a hypothesis. Dreaming is the same basic process as daydreaming, but in a sensory deprivation context. Without the interference of outside signals entering the cerebral cortex through the thalamus, the activations corresponding to imagination and thought become much more salient because they are not in competition with incoming perceptual signals. According to this hypothesis, normal mental events which are happening all the time take prominence in the sleeping mind. We are conscious in dreams of thoughts and feelings and images which would be barely perceptible while we are awake. In the waking state, the richness of perceptual processing from the primary sensory cortices, which are responding to activations from the outside world, is comparably massive compared to the internally generated processes of free-flowing imagination. Once these are out of the way, as in REM sleep, we are left with only these internally generated processes alone. Now these thoughts and images are prominent and compelling. My initial suggestion for testing this hypothesis would involve using waking subjects in sensory deprivation. fMRI might be ideal, but I'm not too sure about lowering a $3 million fMRI device into a sensory deprivation tank. However, it seemed to me that it might be possible to discover that normal waking imagination in the context of sensory deprivation enables the experience of dreams during wakefulness that are indistinguishable from those occurring in REM sleep. Since REM sleep can be distinguished from the waking state using EEG, that technology might have been sufficient to support or refute the hypothesis. So I took a little tour through the research literature and found, first, that the descriptions of sensory deprivation from studies in the 50s and 60s was both methodologically and experientially different than I expected. Mostly, subjects were deprived of visual and auditory inputs by placing them in a dark chamber, a soundless chamber, or by using a blindfold, for example. This is really just single or dual modality deprivation. Unsurprisingly, the subjects came to have visual and auditory hallucinations. These states aren't really dreamlike. The subjects were wide awake, and there was no narrative quality to the experience. Later studies using sensory deprivation tanks get closer to what I had in mind, but I think their use in this context fails to really produce sensory deprivation. In support of that claim, check out this passage from a recent study by Obada Al Zoubi et al., titled "Taking the Body Off the Mind, Decreased Functional Connectivity Between Somatomotor and Default Mode Networks Following Floatation REST." REST, according to them, is an acronym for Reduced Environmental Stimulation Therapy. The authors write, quote, "Decreases in default mode network resting state functional connectivity appear to be a common feature underlying altered states of consciousness, such as when falling asleep or being deprived of sleep, or while under anesthesia or subanesthetic doses of ketamine. A similar pattern emerges under the acute influence of psychedelic drugs like ayahuasca, psilocybin, and LSD, with the degree of reduction in default mode network resting state functional connectivity related to the degree of ego dissolution. Other studies have found that meditative states also elicit decreases in default mode network activity and resting state functional connectivity, especially within the posterior cerebral cortex, a finding which may be related to meditation's ability to reduce mind wandering by not getting caught up in a mental chatter. In contrast, rumination of negative thoughts, as commonly found in depression, appears to be characterized by excessive default mode network activity and resting state functional connectivity. Floatation REST has been found to have short-term anxiolytic, antidepressant, and analgesic effects, yet little is known about how the intervention impacts brain networks such as the default mode network. Subjectively, the intervention has been found to induce altered states of consciousness, often described as a liminal state, somewhere between being asleep and awake. Subjects will also frequently describe out-of-body experiences characterized by difficulty discerning where their outer body begins and where it ends. While floatation rest has sometimes been referred to as a form of sensory deprivation, this term is now considered outdated and a misnomer for the experience. Rather than depriving the senses, we have found that floatation rest actually enhances awareness for internal sensations, such as the breath and heartbeat, making the float environment naturally conducive to meditative states." Unquote. This indicates to me that what is commonly called sensory deprivation is more like a meditative or altered state. Rather than achieving the isolation of the cerebral cortex, in which a high degree of default mode network activity is expected, as when we sit restfully in a chair, or a waiting room, or a city bus, the flotation tank produces a capacity for concentration and meditation. The breath can easily be followed, for example, without sensory distraction. A large and rhythmic sensory experience is felt and heard. This might be entrancing, but it is not an absence of sensation at all. Accordingly here, the authors report decreased connectivity in the default mode network, which might be therapeutic but is not deprived. Probably hallucinations are common under such conditions, but not what I had in mind. In fact, reduced default mode network connectivity is the opposite of what I would want to induce as a test of my hypothesis. There might not be a practical way to test the idea after all. And what about the narrative aspect of the dreams we have at night? Someone telling you about a dream might say something to this effect. "I was with my sister and we were at the airport," or maybe it was a train station. "Anyway, we were in a hurry to get somewhere and we were running. Then I noticed that it wasn't my sister at all, but this woman I used to work with. She was crying because she couldn't find her cat. Then I woke up." I just made this dream report up, but let's take it as a prototype for the sake of conversation. We see the drifting effect here that is common to dreams. Something becomes something else, or someone becomes someone else. The report doesn't have that much additional detail, so clearly this is all that can be remembered. There is the usual amnesia. But most of all, we have a sequence of events which were experienced as happening to the dreamer. This is nothing at all like the hallucinations one would get if you had them sit in a dark room for a couple of days. Assuming that the subject of such a sensory deprivation experiment were in their right mind, a lack of visual stimulation would, in all likelihood, come to produce vivid imagery of the hypnagogic sort. One might see color patterns and things like that, and then perhaps faces, or even full visual scenes. At no point would the subject believe themselves to be in some kind of narrative situation. The subject might report seeing a beautiful cathedral that looked entirely real, or seeing people dancing, for example. These are extraordinary hallucinations, of course, but the subject's report would look nothing like a dream report. What about a daydreaming report? Suppose subjects were asked to immediately write down what they had just been thinking about whenever a little alarm goes off on their wristwatch. This would be analogous to waking someone up during REM sleep in a dreaming study. What would people say? Would they report mind-wanderings of a narrative type? Like, "I was just imagining that I was walking in the woods with my friend Gus when we were kids." Or would they more typically be of a descriptive type, like, "I was listing in my head all the things I have to do to get ready for a camping trip I'm going to go on this weekend." Perhaps during REM sleep, with the prefrontal cortex less engaged than normal, such goal-directed thinking and planning episodes are now impossible. All we could be left with would be imagined scenes or episodes. I don't know, it seems plausible to me. I notice that when I freely daydream, as I do for example when I'm lying down to go to sleep, the narrative of my thoughts is driven by a felt preference for a certain direction. My mind wanders, but not quite at random. Rather, it wanders down paths that I find interesting, at least in that moment. In that sense, I am partially authoring the flow of events. Whatever I fancy in that moment directs the story. I don't have this power in dreams. I don't think, but lucid dreamers seem to. Nevertheless, it's also easy to lose track and find yourself down some weird path or unrelated daydream. This observation could be a third line of circumstantial evidence. Dream sequences don't last for hours. They might last for seconds or minutes and then be replaced by some other, apparently unrelated episode. This is true for the waking mind, and it seems to be true of the dreaming mind too. Sometimes a person will say that they remember 2 or 3 different dreams upon waking up, each disconnected from the others. If I'm asked at some quiet point in the day what I've just been thinking about, and I can remember, I can probably summon up 2 or 3 different lines of thought or imagination too, at least sometimes. This is another matchup between daydreaming and dreaming that shouldn't be immediately dismissed. If I'm right about dreams and daydreams, what are the implications? I think it's a double-edged sword. On one hand, it would suggest that dreams are not archetypal mysteries from the subconscious mind trying to teach us something in their cryptic way. They're not something which necessarily affords interpretation, and we shouldn't expect to learn important lessons from them. On the other hand, the sorts of dreams we have, just like the daytime fantasies and thoughts we have, should tell us something about our personal fears and desires. They come from our own minds, with a flavor of our own personal dispositions. To that degree, they might tell us something of value about ourselves, about what really motivates us. After all, we don't choose our preferences out of thin air when we're fantasizing and imagining events. We prefer them for some reason. In the darkness of our minds, we are free to take any flight of fancy wherever it leads us, while no one else is watching. The weird thing is that in sleep, so much of the dreaming we do is out of our control and leads us astray of what we would rather be experiencing. Dreams are so often stressful and upsetting ordeals. The cerebral cortex conjures a mind so that it can torture it, force it into submission, and exploit it. We, the conscious, are helpless prisoners, each locked within its own cranial chamber. Maybe it's all somehow like the Matrix. To swallow the red pill is to become lucid, to unlock the cell door, and for a short while, take a look about the grounds.